Welcome to this deep dive. This is episode 7, and today we're tackling, well, a pretty substantial collection of information. It's all focused on network communication and management within the AIX operating system.
That's right. And we know our listener, who we're calling the learner, is looking to really get a quick but thorough grasp of the essentials here, maybe uncover some surprising bits, and definitely avoid getting swamped by too much info. So, this deep dive, it's designed just for you.
Exactly. We've got a lot to draw from, mostly detailed IBM documentation. It covers, well, everything from the real basics of TCP/IP right up to more specialized networking tools and protocols.
Yeah, our mission, if you will, is to pull out the key knowledge, the insights, and make this whole complex landscape understandable, maybe even engaging, and importantly, without skipping the crucial details.
Right. We'll be exploring core networking concepts, how things are configured, different ways systems talk to each other, and of course, how to fix things when they go wrong in AIX. So get ready to connect the dots. We'll try and give you that comprehensive but digestible overview.
Okay, so where do we start? The foundation, right? TCP/IP.
Absolutely. The documentation lays out some key terms straight away. You've got host, basically any machine on the network, and each host is a node, which is just an addressable spot that offers processing. Then there's local versus remote. Local is stuff you access directly.
Right, from your machine. And remote is over a wire, basically.
Exactly.
And something the docs really stress is planning. Plan your TCP/IP network before you start installing anything.
Yeah, like deciding on your addressing, how the different bits will connect. It's like planning a building before you lay the first brick, isn't it?
Precisely. Good analogy.
So how do you actually get it running? The docs mention a few ways. There's SMIT, the system management interface tool, kind of menu-driven.
Right, SMIT. Or you can go old school and edit config files directly, like rc.net or the even older rc.bsdnet.
Apparently, SMIT actually sets up rc.net for you. But if you edit rc.bsdnet yourself, you're using standard UNIX commands, if config for interfaces, hostname for the name, route for paths.
The standard toolkit. And the core idea behind the addressing is this two-part structure. An internet address has a network part and a host, or local part.
So you can point to the network and a specific machine on it.
Exactly. If you're connecting to the big internet, you get assigned an official network address. But for your own private network, you've got more freedom to pick addresses.
Originally, this was pretty rigid with these address classes.
Yes, the classes. This bit's interesting. The docs specifically call out Class A. That's an 8-bit network address. The first bit's always 0, apparently.
Right.
And then a big 24-bit local address for the specific host. There's even a little diagram. But, the internet grew way faster than they expected, right? So these classes...
It became limiting, which led to things like CIDR, classless interdomain routing, much more flexible.
And within that local address space, you can divide it further with subnetting.
Subnetting. So you take that 24-bit local part and split it again into a subnet address for a specific physical segment, and then the host address within that subnet. You really have to plan how many subnets and hosts you'll need. Like your building analogy, dividing it into departments, which are the subnets, and desks, the hosts.
Exactly. Planning is key.
Okay, so what about connecting different types of networks, different hardware, different software?
That's where gateways and bridges come into play. A bridge connects similar local networks, maybe different cables, but the same underlying rules, like joining two Ethernet segments. It works at a lower level, just looking at hardware addresses, MAC addresses.
So simpler. And a gateway.
A gateway is smarter, operates higher up. It can actually translate between different network types, different protocols. It's the translator that lets diverse networks talk across the internet.
Got it. The docs also really break down the layering of network communication. You called it a postal service earlier.
Yeah, it's a good way to think about it. Top layer, application layer, that's just your data, the letter.
Down to the transport layer, adds a TCP header. That's the envelope, right?
Yeah.
For reliable delivery.
Right. Creates a transport protocol packet. Then the network layer wraps an IP header around that. That's the main address label, forming a network layer datagram.
Next, network interface layer adds, say, an Ethernet header. Final packaging. An Ethernet frame.
Exactly. Ready for the physical network, the actual wires or airwaves, and the receiver just reverses it, stripping headers off at each layer. The diagram they include is actually quite helpful.
It is. Now, moving forward to IPv6, the docs talk about scope. like link local addresses derived from the MEC address.
Right. For communicating just on the local wire, no extra setup needed, like an internal office phone line.
What's neat is how IPv6 prefixes tell you the scope of link local, site local, global, multicast, unicast. You can just look at the start of the address.
Yeah, much clearer than IPv4's broadcast and class distinctions, and IPv6 handles assignment differently too.
And just quickly for any token ring users still out there.
If there are any.
Yeah. The docs mention the unnumbered information frame, UI frame, hex value by 03. That's the standard data frame. The key thing is TCP/IP handles the sequencing on top of it because the UI frame itself doesn't guarantee order.
Good detail. Okay, moving on from the fundamentals. Communication methods. How do AIX systems actually, talk?
The docs give an overview. File transfers, printing remotely, email, and something called BNU basic networking utilities.
Let's start with file transfers. FTP is the classic command mention. Defaults to ASCII mode, remember?
Right, fine for text. But you need the CD subcommand to move around directories on the other end, and definitely use the binary command if you're transferring programs or images. Otherwise,
you get corrupted files. Yeah, crucial point.
Then remote printing. Commands like LPR, maybe others. Depends on the setup, really, sending jobs out, getting results back.
Standard stuff. Now, email. The mail program gets a fair bit of coverage.
The basics. Reading, deleting, forwarding, commenting when replying, storing mail in your inbox or in specific folders you create.
And SendMail, the agent that actually moves the mail around, gets installed automatically on AIX, apparently.
Customization seems big with mail. You can tweak a file called mailrc in your home directory.
Right, mailrc. You can use set folder to specify a directory for your mail folders, makes saving easier with the +sign shortcut.
And you can control the prompts for subject and CC using set ask or unset ask. Useful if you're scripting mail.
And aliases. For single addresses, you can create short names or distribution lists for groups. Saves a lot of typing in, not mailrc.
Inside the mail program itself, there are display commands. T plus a message number shows that message.
N shows the next one. F shows you the headers, like a summary.
When you're actually writing an email, how do you send it?
You hit Control-D on a blank line or just type a dot period on a blank line. That sends it off.
And if you need to mess with the headers while writing,
there are tilde commands. H lets you edit to, subject, CC, BCC all at once. T adds to the to field, S for subject, C for CC, B for BCC.
What about adding stuff to the message body itself?
More tilde commands. D grabs your dead.letter file content. R, followed by a file name, reads that file in. F or M, followed by message numbers, pulls in other messages. M even indents them, good for quoting.
And editing the message you're composing.
E uses your default editor, whatever editor is set to. V usually fires up VES.
Okay, let's shift to those basic networking utilities. BNU, what's the deal there?
BNU is, well, basic, often for batch stuff between systems, file transfers, remote commands, printing, even email. Kind of an older way of doing things, but it's in the docs.
It has its own way of working, right? Special files and directories?
Very much so. Hidden directories, often starting with a dot. Key locations are var_spulucup for queued stuff and eqcup for configuration.
And the config files themselves. There are a few.
Yeah, eqp systems defines the remote machines you talk to. eqp devices describes your local modems or serial lines. eqp dialers tells it how to dial different modems. eqpc sysfills lets you put these files elsewhere, interestingly.
And eqcup permission sounds important.
Crucial for security, it dictates what remote systems and users can actually do, which commands they can run, which files they can touch.
How do you maintain this? Check logs.
Yep. Logs like varspool_sulog for UECP logins, maybe varspool_cronlog if jobs are scheduled, and cleanup tools. You clean for old spool files, you uppick to manage received files, ustat to check the job queue status.
And the paths look different in BNU.
Sometimes you can use normal Unix paths, relative paths, or this system name.path format.
Ah, the bang path.
Exactly. System1.system2.path for multi-hop stuff. A relic, but there it is.
What actually does the work? Daemons.
Two main ones. Usuco handles the connection and file transfer, the actual talking between systems, and Ususco executes commands received from remote systems.
Security, again, the permissions files key, and special login IDs.
Right, login IDs usually in the UTIP group. Remote systems log in with these, need passwords. When they call in, Usuco starts up automatically on your end.
And the commands for using bnu.up for copying files?
Yeah, ucup is general copying. Uto is specifically for sending files to a user on another system. They get notified somehow.
And UCUS lets you run commands remotely.
Correct. UCUS executes a command over there, maybe sends output back here.
Troubleshooting BNU. Any specific tools?
Well, the status messages from the commands help, and UNOSNAP gives you a quick snapshot: who's connected, how many files are waiting for each system. Pretty handy.
Okay, let's move to something probably more familiar to many. NFS, Network File System, or STNFS as the docs sometimes call it.
Right, NFS. The docs have a checklist for setting it up. First step: make sure the NFS daemons start automatically when the system boots.
Makes sense. Configuring the server side involves its exports, right? That file says what you're sharing and who can access it.
Exactly. Its exports is central. If using Kerberos for security, there's extra setup. For NFS version 4, you also need to set the NFS v4 domain with Nationist.
And on the client side, you use the mount command.
You can mount explicitly with mount, or, more permanently, add entries to its setter file system so they mount automatically at boot.
Identity mapping is mentioned too. That's about matching user IDs between client and server.
Yeah, making sure permissions work correctly across machines. Important.
You can control what's shared on the fly with exports.
Correct. Exports to make things available, exports some to unshare them. ShintFS lets you tweak options for already exported systems, like root access rules.
And the automatic mounting, there's an automount subsystem mentioned.
Yes, automount provides a more dynamic way, often using setter file systems or even separate maps, like LDDAP apps. And you can remove predefined amounts through SMIT or by editing setter file systems.
The docs also briefly mention PCNFS.
Or PC authentication, yeah. And LDAP automount maps for central management, WebNFS for access through firewalls, usually.
What about file locking? NFS is stateless, so how does that work?
The network lock manager. That involves rpc.locked on both client and server to handle lock requests, and rpc.statted, also on both sides, to monitor if the other machine crashes.
So rpc.stat tells rpc.locked if a machine went down and came back, so locks can be reclaimed.
Precisely. It's crucial for maintaining consistency after failures.
Security with NFS, beyond basic host access.
Kerberos is the big one mentioned for stronger security. Troubleshooting often involves rpsfinfo to check if the necessary RPC services are running, and just checking the status of the main NFS daemons.
Keyfiles.sexports on server, it's set to NFS local domain, keyamans.exports, mount kinestum.
And the daemons, NFSD, mount, port map, rpc.statted, rpc.locked, NFSRG for the registry, GSSD for security services like Kerberos. It's a whole ecosystem.
And quickly, NFS ACLs for finer permission control, and a no-uckle mount option to disable them.
Right. Plus, NFS v4 features like a grace period for reclaiming locks after a server restart, delegation of tasks to clients, and support for data replicas.
Okay, deep breath. Let's dive deeper into the protocols themselves, starting with TCP. Reliable, connection-oriented, stream-based.
The reliability comes from things like sequence numbers for order, acknowledgements for received data. Connection-oriented means you set up a connection first, defined by the socket pair, source of destination, IP, and port.
And stream-based means it treats data like one continuous flow, not separate packets.
Correct. The docs mention TCP headers can carry precedence and security markings, but routers might ignore them.
And the header structure itself is detailed. Source port, destination port, sequence number, ACK number, data offset, reserved bits, code bits.
Yeah, SYN, ACK, FIN, RST flags, window size for flow control, checksum, urgent pointer, options, padding, and then the actual data. The diagram helps visualize it.
Complementing TCP is IP, Internet Protocol. Unreliable, connectionless, packet-based.
Unreliable meaning no guarantee of delivery. Connectionless means no setup phase. Its job in the network layer is to take data from transport, slap on an IP header with addresses, figure out the next hop router, and pass it down to the network interface layer.
And that network interface layer, like Ethernet, takes the IP datagram and puts it in a frame with MSE addresses for the local network delivery.
Then there's ICMP, Internet Control Message Protocol, for feedback, right? Errors.
Exactly. Not making IP reliable, but reporting problems. Like if a router can't reach the destination, it sends an ICMP message back.
Destination unreachable. Every IP implementation needs ICMP for error reporting and diagnostics, like packet too big, host unreachable, port unreachable.
UDP, User Datagram Protocol, is the alternative transport. Unreliable, connectionless, but faster than TCP.
Yeah, less overhead. Good for things where speed matters more than guaranteed delivery, or the app handles reliability itself. Think streaming or games.
ARP Address Resolution Protocol, that maps IP addresses to EMP-KIM addresses on the local network.
Essential. Before sending locally, you need ARP to find the hardware address for the target IP, mentioned regarding cache timer values.
And DHCP Dynamic Host Configuration Protocol, Automating IP address assignment saves a ton of work.
Absolutely. Covers DHCP-v4 and DHCP-v6. Also mentions PXE, proxy DHCP, and BINL daemons for network booting.
Server config is hacdhcpsd.cnf. Started via rc.tcp SMIT or SRC.
Client config via SMIT or a flat file. Server keeps track in a database, dbfile.dhcpo. Logging is controlled in the config file too.
And it can update DNS automatically, dynamic DNS.
Right, DDNS. Using NS-updated daemon and server policies like hostname policy, proxy rack, append domain, so hostnames match IP leases.
Lots of DHCP options mentioned too. Tab BIOS stuff, requested IP, lease time.
Options 46, 47, 50, 51, plus PXE vendor options for booting, DHCP-v6 keywords.
PXE itself has its own engine and config file, phd.cnf.
And DHCP option management uses this container hierarchy strict versus regular client class vendor subnet priorities, address ranges managed within those containers, carefully avoiding overlaps.
Okay, RDS reliable datagram sockets, bypassing the kernel stack.
Yeah, for high-speed networks like InfiniBand or RoCE, uses AF-BY-Pass. AIX has RDS-v2 and RDS-v3. With RDMA support, you create the socket with a socket call.
SCTP, Stream Control Transmission Protocol, another reliable one, but message-oriented.
Right, message-oriented, multi-streaming, multi-homing. Avoids TCP's head-of-line blocking, more resilient with multiple IP addresses. Mentions subroutines like CTP get pattern to get peer addresses.
Routing protocols, EGP, Exterior Gateway Protocol, older, between autonomous systems, not shortest path.
Then RIP and RIPing for IPv6 interior protocols, simpler, distance vector-based.
And OSPF, open shortest path first. More complex, link state, better for larger networks. Also an interior protocol.
Mobile IPv6 support is mentioned too, for devices moving between networks. Concepts like binding updates, home agents, correspondent nodes, it sets trc.mobip6 is the config file.
VIPA, virtual IP addressing, not tied to hardware.
Correct. Offers advantages over IP aliases, can be brought up down independently, moved between physical interfaces without disruption.
Ether channel or link aggregation. Bundling Ethernet adapters for more bandwidth and redundancy.
Up to 8 primary, 8 backup adapters. Need to watch adapter limits, maybe tweak diff size. Simpler network interface backup NIB exists too.
An IEE 802.3 ad using LACP, that needs coordination with the switch, right?
Yes. LACP exchanges messages, LACP to use, with the switch. Speed and duplex must match. Mentions considerations for HEA logical ports and SRIOV adapters too.
Back to ARP quickly. ARPIA shows the cache.
ARP-DD deletes an entry, and you can tweak the timers for complete and incomplete entries with ARP commands or if config options like InTimer and ComeTimer.
Finally, ISCSI, storage over IP networks.
Block-level storage access remotely. Software initiator config involves discovery file-based, XSC targets, or ODM-based, and KISI.
Mentions software target considerations, incompatibility with loopback, and performance tuning.
Yeah, MTU size, TCP send receive spaces, TCP send space, TCP pre-TV space, SB max no option, maybe disabling NAGL with TCP NAGL limit.
Phew. Okay, let's talk about the daemons and utilities that actually run all this stuff.
The background processes, controlled via system commands, other daemons, scripts in mated, rc.tcpip, and SRC, the system resource controller.
SRC manages subsystems and subservers. In mated is a key subsystem acting as a super server.
Exactly. It listens on many ports and starts the right subserver daemon, like FTPD or Telnet, when a connection comes in. Saves resources.
You configure inated in etsiniti.conf, maybe using SMIT. Mitigated. Then start it with start SRC beth init.
For routing, there are daemons like routed and gated. They maintain the routing table.
If a machine isn't a gateway, you run them passively, just listening.
Right. Static routes go in, X categories for routed, or the more complex gated.conf for gated.
And these support RIP, RIPing, OSPF, EGP, gated.com has specific syntax, especially for IPv6.
That's correct. Then send mail daemon for email. -X option for logging traffic, but watch out, it's verbose.
CESR1 signal dumps open files and cache info, useful for debugging, and libmilter for mail filtering.
Yeah, external filters using callback functions like exitid.from to check incoming mail.
IMP and POP servers enable them in exitid.com, refresh and edit, test with telnet to the ports.
Ports 143 for IMAP, 110 for POP3, 993, 995 for the SSL-TLS versions. Then check logging via syslogged.
Configure at exitdirtlog.com, maybe touch the log file, refresh syslogged. Mentions bug filer for mail bug tracking too.
Network status commands, host for DNS lookups, ping for reachability, who to see who's logged in elsewhere if rhoot is running.
Remote logging command tools. Recsec, single command. Arrow login, airshrems, telnet tn3270.
And talk for interactive chat, if talk is enabled.
File transfer commands besides ftp.rcp for trusted non-interactive copies, TFTP for simple, often unauthenticated transfers.
Okay, troubleshooting. Always important. Starts with that planning checklist. Again, good planning prevents problems.
Authentication issues are common. .NET JOC for FTP, .ROST@CHOS, .equivalent for passwordless access, Kerberos problems.
Remote login failures. Password prompts when you don't expect them. Often tied to those files are network issues. Remember to escape a stuck login.
FTP issues. Need to log in. Remember binary mode for non-text files.
Ethernet problems often physical. Check cables, connectors. For old Thinnet, check T connectors and terminators. Verify the adapter card.
Token ring. Check the ring speed setting and semi-T. Make sure it matches the network.
If a token ring Ethernet bridge seems okay but things fail, check if the AIX Ethernet adapter is dropping packets.
SLIP, the serial line protocol. Configuration issues, SMIT/CHAINET, testing with ping. Modem problems are common. Check echosts.
Use /hatch to start it. If config sselshtack up to activate it, SMIT/sherman to remove it.
Modem connections themselves. Check result codes, dial string in /hatch, auto answer setting. Use Q to talk directly to the modem for testing. Noisy lines, bad settings.
Q is invaluable for that low-level modem diagnosis.
Right, let's switch to SNMP Simple Network Management Protocol for, well, managing the network.
More structured than just basic TCP/IP comms. SNMP v3 adds security. Keys generated with PWToki.
Config files, that's header, snmpdv3.com for the agent. It's at cclsnmp.com for command line tools. Need to define users in both for v3.
VACMU-based access control is key for security. Who can see what MIB data? Define with VACM DRUP entries in snmpdv3.conf.
Traps asynchronous alerts from agents. Configure destinations with trap entries in snmpdv3.conf. Maybe need at snmpdv3.com too. Listen with CLSNMP trap.
The trap PDU has a specific format. Enterprise ID, agent IP, trap codes, timestamp, variable bindings with details.
MIB Management Information Base. Database of managed objects. Docs mission MIBs for EGP, token ring, FDDI specifically.
Use SIMPunfo to get specific values. Send SEMWalk to browse the MIB tree. Standard SNMP tools.
Okay, nearly there. Serial communication aspects. RANs, remote asynchronous nodes for adding more serial ports.
Serial basics, start-stop bits, marketal state, flow control. Hardware, DTR, DSR signals, or software. XON, XOF characters.
GUIs, teletypewriters, character terminals. Manage them with SME, SMIT, MDABTD, CheetRef, RMDev. Docs list error messages.
Modem standards. ITU, TSS, VNN, MNP classes, full versus half duplex, EIA, 232D signals, TXD, RXD, RTS, CTS, DTR, DSR, CD, RI, Haze AT commands for control.
PPP is a more modern alternative to SSLP over serial. 8 utility for direct terminal emulation, D-screen for virtual screens.
DLC device managers like SDLC, IE 802.2, various asynchronous adapter cards supported by AIX, 8-port, 16-port, troubleshooting modem issues, check Getty respawning, settings, cabling.
Finally, QoS quality of service, prioritizing traffic.
Emerging tech back then, included in boss.net.tcp.server file set, configured in etcpolicy.com to find service categories, policy rules for marking, DSCP, or shaping traffic, references diffserv RFCs.
Okay, wow, that was a lot. Let's try and quickly recap this deep dive into AIX networking. We covered TCP/IP fundamentals, communication tools like mail and BPO, NFS details, protocol specifics, troubleshooting, SNMP, serial stuff, even QoS. We really tried to hit all the key points from the source.
Yeah, and for you, the learner, the big takeaway is you should now have a pretty solid foundation in how AIX handles all this network interaction, from the low-level packet stuff right up to the applications users see.
All those details, like the TCP headers, the config file names, its sexports, its SC, DHCPSD.CNF, a Q, they give you real insight into how it all works mechanically under the hood in AIX.
So what does it all mean for you? Well, hopefully you're better equipped now to understand your network setups, figure out what's wrong when issues pop up, and just appreciate the level of control AIX gives you.
It really paints a picture of how interconnected it all is, doesn't it? Adapters, daemons, utilities, everything working together.
It does. And that leads to a question for you to think about. How do these principles we talked about layering, protocols apply elsewhere? In other operating systems, other networks you work with, the core ideas are often quite similar.
Good question to ponder. And that wraps up this particular deep dive. For our next one, episode 8, we're changing lanes completely. We're going into AIX programming.
That's right. We'll be looking at SDKs, the software development kits, the essential compilers you need, and importantly, the debugging tools developers use in the AIX world.
So get ready to explore the developer's toolkit on AIX in our next deep dive.